The topic for this lesson is about RC time constant. We are going to discuss what is this RC time constant about, the formula used to calculate this RC time constant, and why is this RC time constant useful. At the end, I have two figures to show you how does this RC time constant affect the capacitor's charging and discharging speed. Most likely, the first question is, what is this RC time constant about? RC stands for resistor capacitor. So the RC time constant is a number that's relevant to this resistor capacitor circuit. For this session, we are only interested in RC series circuit. That means a circuit has only a capacitor and a resistor connecting series. We use a Greek letter tau to represent time constant. For a RC series circuit, the time constant is resistance times capacitance. Since the unit of resistance is ohm and the unit for capacitance is farad, the unit of tau is omega farad. You may wonder why this time constant is useful. This time constant tau gives us an idea about how fast the capacitor charge or discharge in the circuit. When we learn electronics, we can always find something related to water and use it as an analogy. For example, the electric current, just like the real current, water, and the resistor, just like rock or dirt in the river that blocks the water flow. We can think capacitor is like a container, like a bus stop or a swimming pool. How about we use the swimming pool as an example? Here, let me draw a big swimming pool. And the opposite side, we have a small swimming pool. Now I want to pour water into the big swimming pool. For a bigger swimming pool, it takes more time to fill. I use the same pipe, pour water into the small swimming pool. For a small swimming pool, it takes less time to fill. The way of capacitor works is similar. For a big capacitor, it takes more time to charge. For a small capacitor, it takes less time to charge. On the other hand, if the swimming pool is filled, and now we want to dump all the water, it takes longer time to dump water from big swimming pool. Similarly, it takes more time to discharge a big capacitor, and it takes less time to discharge a small capacitor. This is the fundamental concept of capacitor. If you understand this very well, I'm pretty sure the later lessons are not too hard for you. In conclusion, it takes a long time to charge a big capacitor and less time to charge a small capacitor. Resistor in the circuit also plays an important role in terms of capacitor's charging speed. For example, let's say we have a big resistor in the circuit. Less current flows in the circuit. With little current, it takes more time to charge the capacitor. For a smaller resistance in the circuit, more current flows in the circuit, so it charge or discharge capacitor faster. One example is to design a low-pass filter. If we already know what kind of features we want to put on this filter, by choosing the correct capacitance and resistance, we can make this filter. Now let's look at the figures to analyze deeper. The first graph shows the amount of charge changes versus time for 3 different RC circuits during charging capacitor. The first curve on the top has a small time constant of 1 tau. It is fast to charge. Comparing to the middle curve, which has a larger time constant, 2 tau. The curve shows it takes relatively longer time to charge capacitor. Among all 3 curves, the third curve has the largest time constant, 3 tau. It takes the longest time to charge the capacitor. The second figure shows discharging capacitor. The curve with the largest time constant 3 tau, capacitor discharges slowly. The curve with a time constant of 2 tau, its capacitor discharges relatively faster. And the last curve with the smallest time constant tau, capacitor discharges the fastest.